The Greater Everglades ecosystem is ruled by water. Fresh water slowly filters through shallow marshes, funneling into creeks and rivers before spilling out into Florida Bay. Seasonal hydrologic shifts define the unique subtropical region with rain-filled summers and dry winters. In this tenuous climate, wildlife manages to cope with extreme conditions. In fact, the flora and fauna of the Everglades and Florida Bay, particularly wading birds, have come to depend on the annual rise and subsequent drawdown of water. During the summer, consistent rainfalls raise water levels throughout the ecosystem, allowing aquatic invertebrates, amphibians, and fish to reproduce and disperse across sloughs and sawgrass prairies that fill with water. However, from December to March, the winter months usher in the dry season, and soon, the once submerged wetlands become parched basins. With fewer places to go, fish are forced from the shallow wetlands into the slightly deeper creeks and rivers until the rains return in June. Wading birds time their nesting with this seasonal drawdown cycle. In order to successfully forage enough food to sustain their young, they depend on the high concentrations of fish found within confined areas. For over 20 years, scientists at Audubon's Tavernier Science Center have studied the relationship between fish population densities and seasonal water levels. For 8 months out of the year, biologists sample 19 sites with varying salinity gradients from Cape Sable to Biscayne Bay. Accessing many of these sites requires boating across Florida Bay and into the far reaches of Everglades National Park backcountry. Along winding creeks and through seemingly endless mangrove tunnels, scientists go to great lengths to collect their data. In fact, 4 sample sites are so remote that access is only possible by helicopter. These isolated freshwater habitats give biologists a better idea of what southern Florida once looked like before canals allowed saltwater to penetrate the interior portions of the Everglades. With cumbersome equipment, pre-dawn departures, and sites located miles away from the nearest road, it proves no easy task to conduct research in Florida's southernmost wilderness. It typically takes 3 days to complete just one sample at each research site. In order to account for the subtle habitat variances within the site, nets are placed in shallow mudflats, in deeper creeks, and in open water where submerged aquatic vegetation blankets the bottom sediment. Sampling in all 3 microhabitats allows scientists to compare the differences in prey abundance between the wet and dry seasons, as well as the influence of submerged aquatic vegetation on the demersal fish populations. On the first sample day, nets are carefully set with pull strings so biologists can return the next day and drop the net while maintaining a distance to avoid alerting the fish to their presence. On the second day, biologists must drop all 9 nets within 3 hours of sunrise before the suspended nets cast a shadow and affect the fish's behavior. Once the net is dropped, biologists collect the fish, making sure to search the area thoroughly. Each fish species is critical to the overall sample. On the third day, any remaining fish are collected and the nets disassembled, leaving no trace of the sampling behind. Back at the laboratory, Audubon biologists identify, weigh, and measure the prey-based fish from each sample site. Painstaking and smelly work, they properly catalog each and every fish. Within an individual sample, the number of fish, as well as species diversity and composition, gives important clues as to the health of the wetlands. Analysis of this data unveils the effects of both natural stressors, such as prolonged dry seasons and unnatural stressors like releases from man-made canals that disrupt the annual drawdown of water levels. By continuing this monitoring program, the Tavernier Science Center will be able to determine the effects of Everglades restoration projects. Properly managing the delivery of fresh water to the southern Everglades will increase the productivity of the wetlands, resulting in greater abundances of prey-based fish. From birds to reptiles to game fish, these demersal fish provide the basic food source for the entire ecosystem. This ecosystem also drives the local economy, and while millions of visitors come to the Everglades and Florida Bay each year to see the top trophic feeders like alligators, crocodiles, osprey, and tarpon, the true unsung heroes of this wilderness are the unassuming, small demersal fish. With them lies the success of all fish-eating animals of South Florida. Without them, however, there can be no Everglades.